Hi everyone, thank you for joining me. Did you know you can actually use the integrated area of a peak in order to calculate the concentration of that peak, especially for a fraction? The reason you can do this is because that integrated area is essentially the same as using a spectrophotometer. In order to do this though, you do need to know the absorbance of a 0.1% solution. And that ratio, like I call it the absorption ratio, has to have units of mils per milligram per centimeter. And we're doing these measurements at 280 nanometers because we're using the UV curve in order to do this integration. So let me show you how to do that in Unicorn. Real quick though, this image is from the streamlined version of Unicorn that's available in Unicorn 7. Today I'm going to be showing you how to do this in Unicorn Classic, which is a slightly more complicated. Okay, so let's go to Unicorn. Alright, so here we are in the Evaluation Classic module. Just because we're starting... What's that going on? Okay, escape. There, okay. So here we are in Unicorn, and so we're still doing introductory videos. How you find the evaluation module is you click the Unicorn button down here, and then you go to the sub box here that's got the little E on it. That's the evaluation module. And then here you are inside of the evaluation module. Your screen may look something like this. This is the streamlined version of the evaluation module. So to get there, you just click Applications and then switch to Unicorn Classic. All right, so now that we all know where we are, I am going to use a result file, which is from a chromatography run I did a few years ago. And this one's interesting because it's got two peaks. All right, so first off, you actually have to do the integration, and we're just using the UV curve here. We're not going to be using like the conductivity curve. I've shown this in this particular run in some of my other videos. In order to do that, in order to integrate that peak, you would think that you would go over here to integrate and just hit peak integrate, and then we'd use the UV absorption. And maybe we would reject peaks and define a peak window. So why don't we just do that really fast? We'll go here, we'll do a zero baseline as well. We'll just do I don't know, the top 5 peaks. So you can change the baseline calculation right here by selecting zero baseline. Let's just do this. Okay, so here we have some little mini peaks over here to the side. Those don't really matter. We're just going to focus on these two peaks. You'll notice that there is no space in here to actually type in the UV absorption ratio that we're looking for. You can modify, customize this peak table, and you do that by going down here to customize. And again, there's no place, place to select there's no column to select that would give you the absorption ratio to type in. So we can't do that. You don't actually, after saying all that, basically all I'm saying is you don't actually use the integration function. You go over here to operations and you select the fraction histogram, and I'm just going to click that, and then here we go. And what's going on at the top is that you're selecting the curve, right? And then the source chromatogram, and then this is the target curve that we're going to pick, right? And then the fraction histogram comes up right here. So I can just start typing in. Let's say that this first peak is my protein of interest, and this second peak is my impurity. And I know there's going to be some mixing because of Gaussian skimming in between here, but for our purposes, let's just say B2, B3, and B4 are our pure protein, and that's what we're looking for, right? It just simplifies everything. So we can type in that extinction coefficient. We're just learning how to use unicorn. All right, so I could type in the protein concentration for each of these. Sorry, the extinction coefficient in order to find my protein concentration. But you'll notice that it gave me different numbers for each one. So, this is helpful, but unfortunately, it doesn't give us, if we pooled all these fractions together, it won't actually give us a single number for all three of these. You could sit down and probably figure it out. You could also just pool them together and measure them on a spectrophotometer, but that's not what we're interested in doing. So we'll figure out how to pool these in just a second. One of the things I want to show you though is that I can only export the table or print the table. If I hit OK, this fraction histogram just goes away, disappears, which in my opinion is really frustrating. At least the work I did here of typing in the extinction coefficient. I would hope that that the table appears here, but it doesn't. And I haven't figured out a way yet to get that table back where I typed in the extinction coefficient. So let's pool these fractions inside of Unicorn, and we're going to do that by going to Operations and then Pool Fractions right here. It's just right underneath the fraction histogram. All right, so we said, let's pull this over here. We said that we're going to say that B2, B3, and B4 are our purified protein that we're looking for. So we're going to click these three right here, and we're going to overwrite, it's like this pink line, right, which is curve 16. We're going to overwrite the old histogram. You know what, let's leave that there, we can compare them. We'll hit OK. Alright, so the pooled fractions, okay, I guess it doesn't, it has the same histogram shape right there. You notice there's a little marker right here which shows us what where the one peak stops, right? Okay, and so now we can go to Operations and Fraction Histogram again, all right? And we had curve 11 was what we originally used, and here's 17. So if I click this, now see it doesn't come back up. All right, so the target chromatogram and curve is going to be 18, right? So we've created a new curve for the fraction, for the pooled fractions. And see here, we can see that the fractions B2 through B4 have been pooled. And B2, B3, and B4, yep, that's what we're looking for. So now, if I type in the extinction coefficient here, it'll give us the concentration of all three fractions together, 1.4. Okay, so I'm using 1.4 is the extinction, sorry, not the extinction, it is an extinction coefficient, but it's the absorption ratio for antibodies. And most antibodies are like 1.2 to 1.6, so I'm just using the average one. Like almost all antibodies are 1.4, honestly. But your protein could be anything. So that's how you calculate the protein concentration. In the other example, so like in the other example, like I've pulled samples off. Like I didn't do it for this run. I did this run years ago. I pulled samples off and I've actually measured the protein concentration. It's dead on, as long as the absorption range is still in the linear range. And I find it's linear up to about 2 absorption units. So that'd be like 2,000 milliabsorption units. So let me show you how to calculate this number really fast. So like I said, most antibodies are 1.2 to 1.4. If you wanted to, 1.2 to 1.6, but 1.4 is like the one like almost every antibody is. But let me show you how it's calculated. I think I said this earlier, but basically the absorption ratio is the extinction coefficient divided by the molecular weight. And so for an antibody, a lot of antibodies, like this example, it's 210,000 divided by the molecular weight of 150,000. Yeah, so that gives you 1.4. And I just pulled this example from a Thermo Fisher document. And you can actually use this absorption ratio like on a spectrophotometer. So if the spectrophotometer gives you a number of like 0.675, dilution factor of 10, you just divide that by 1.4, right? And that gives you your concentration. No need to like type out all these zeros. If you don't have your extinction coefficient or molecular weight, you can actually calculate it using like certain online tools. My personal favorite is the Xpasi ProtParam tool. And all you really need is a protein sequence for this. Most people who have their protein sequence have gone through the effort of calculating the extinction coefficient and the molecular weight because it's so easy. This is something that a lot of students do in introductory biotechnology classes, but I don't know who's watching these videos, so let's do it together. I just pulled this protein sequence from bovine serum albumin, so I'm just going to copy this, and I got that protein sequence from PubMed. And let's go to Google. So I will meet you at Google. All right, so here we are at Google. This is the ProtParam tool. I'm just going to click on it. And the reason I like it is because it's very straightforward. I'm just going to paste my protein sequence in here and then hit compute the parameters. So, the calculator basically, reiterates our protein sequence, breaks down the protein by, its amino acids, but it also calculates a molecular weight, a theoretical PI, which can be helpful, and also a theoretical extinction coefficient, which is right here. Okay, and but not only does it do that, but it does the work for us of finding what the absorption ratio of a 0.1% solution is. And this is the absorption ratio that we're going to put in. And of course, this is for a certain configuration of cysteines. Given certain conditions, there may be other configurations and other absorption ratios you want to use. But I find this one is typically the best. It's what lines up the most. So let's go. I could end the video here, but I want to have some fun. Let's take this unit, this number we calculated, and let's actually put that into unicorn. So we'll go back there to unicorn, and we'll just hit operations, fraction histogram, and I want to use the pool fraction, right? So that's this guy. And what was the number again? Was it I've made a couple of these videos, practiced making them, and every time I do it I forget the number. I know it's 0.7 and I think it's 4.2. I think a couple times I've said 6.2, but it's 0.742. Please forgive me if I got it wrong. If you're watching the video and you rewind, come back and forth, and that's not right. It's it's whatever the calculation is supposed to be. So I'm going to hit enter, and there's my calculation. Okay, it's that easy, folks. Thank you very much for watching today. If you have any suggestions for other tutorial videos you want me to do, just leave a comment below.